Assalamualaikum and salam sejahtera to all of my students. Okay, we continue our topic in chapter 3. The title is AC power analysis. For the chapter content, we covered three topics here. 3.1 is instantaneous and average power. But for the maximum average power transfer, we not cover it in this topic because actually it is the continue from the Thevenin concept actually in chapter 2. Okay, the next we cover for 3.2 RMS value and apparent power. The last one is 3.3 complex power and power factor correction. For the course outcome, at the end of this chapter, students should be able to know the difference between instantaneous power and average power. Okay, except for this, learn the AC version, we don't cover it here. Next, learn about the concept of effective, or we call it RMS value. Learn about the complex power, apparent power, and power factor. Understand the principle of conservation of AC power. The last one, learn about power factor correction. Okay, student, we start the first topic is 3.1 instantaneous AC power. Given here, one series circuit. Figure above shows a circuit which an AC voltage source, which an impedance, connected which an impedance in series. Okay, here we have AC voltage source connected in series which impedance. Okay, impedance either is resistance, capacitance, or inductance. Okay, connected in series will produce current here. So current is outgoing from the voltage source entering to the impedance. Okay, in this case, the resultant current IT will reach the time. Remember, we now here in AC analysis. Okay, so the instantaneous power also will reach with time and is defined as the product of the voltage and the current. Remember from the first topic, remember from the first chapter, we already learned about V, T and IT. Okay, so it's a consists of VT, Vm cos omega t plus theta. Im current, we have Im cos omega t plus theta I. Okay, product of Vmi is produce power. We call it instantaneous AC power. PT equals to V multiplied by I. The unit is in watts, or you just put it as a W. Okay, student, what is instantaneous AC power? Instantaneous AC power is the power at any instant of time. In this slide, I will show you how to get instantaneous power equation. So you have V and I equation. So you just put back the PT equals to V multiplied by I. Just put back the equation of Vm and Im here. So you get here equation. Okay. Then you do the extension from this equation. You will get Vm Im cos omega t plus theta I. Okay, so just the simple multiplication, just put back in this equation, this arrangement. So from this arrangement, you have two cosine of the equation represent as from the voltage and current. Okay, voltage and current here. So how to solve? You can use the trigonometric identities to do the simplification method. Okay, so cos A cos B equals to half in bracket cos A minus B plus cos A plus B. So how to know which A, which B, which one is A, which one is B? Okay, very clear. Okay, from when you compare from these two equations, you get, okay, omega t plus theta V is represent as A. Okay, so omega t plus theta I represent as B. Okay, so cos A cos B is come from this equation. So when you do the elaboration of the equation, so you now get half Vmim, okay, the rest. Okay, so how to get this equation actually is from here. Okay, is from here. So half cos A minus B and plus cos A plus B. Okay, remember this half is here when you do the multiplication, half cos A minus B and half cos A plus B. So now you get both equation is in half here, first part and second part here. Okay, for Vm cos omega t minus omega t theta v minus theta I, how you get here? Okay, from here you get cos, okay, cos, you have omega t plus theta v. Okay, now is the minus, right? Here is minus, so minus omega t plus theta I. Okay, so when you do the subtraction here, so omega t minus omega t, you get this equation. Okay, so theta v minus plus theta I, so you get theta v minus theta I. So you get this equation. Same as a second part, just put back. Okay, so cos omega t plus or cos omega t plus theta I, so you get omega t plus omega t. The next one you get theta v plus theta I. You just rearrange back this one as a plus. So omega t plus theta v. Okay, sorry, I will erase rearrange back the eraser here. Okay, so when you do the sub addition, so when you get for this second part, so half, remember half again, you rearrange back the equation, so omega t plus omega t, you get omega t plus omega t. So theta v plus theta I, so you get theta v plus theta I here. So the next equation you get subtraction, you get minus here. Okay, so this theta v, sorry, this one is cancel out. Okay, cancel out, you get 0 because the same parameter value. So now you have theta v theta I here. Okay, theta v theta I here. Okay, now half cos omega t plus theta v, that's mean double, so you get here 2 omega t plus theta I and theta I. So this one, okay, this one is the instantaneous power equation. Okay, here I want to show you the relationship between these three waveform of I, V and P. Okay, so if you can see here, okay, the equation for the PT is come out from the, okay, from V and I you get here. Okay, from V and I, so you have here is I and you have here is V. So the third one is the PT. Okay, how the waveform look like. Okay. Student, the instantaneous power actually consists of two parts. Okay, the first part here and the second part is here. So the first part, as a, we call it as a constant part. The second part, the part which is function of time. Okay, so you can remember the first part, okay, is a constant part. The second part is sinusoidal power. That means double of the frequency. Okay, student. Okay, I give you one example of instantaneous AC power. Okay, example 1. The excitation voltage and impedance of a series circuit are given by Vt 15 sine omega t, and the impedance is Z 5. The angle is 10 degrees. Okay, determine the instantaneous power. Okay, so P, you know, P equals to Vt multiplied by I T. Okay, so the simple circuit you can drawn here is like this. Okay, so the solution, okay, you get first the equation of Vt. You have Vt equation, but the equation is in sine, so you transform first in cosine function. You get 15 angle minus 90 degrees. So the rest you must get the value of It. Okay, so now you can use Ohm's law. Ohm's law state V equals to Iz. So now you have the value of the impedance Z. So rearrange back the equation of Ohm's law, you get It equals to V divided by impedance Z. So rearrange back the value and you calculate by using the calculator, then you get the value is 3, the angle is minus 100 degrees of current, unit is ampere. Okay, so now you get both V and I, the value of V and I, so you can put the value in the PT equation, in the instantaneous power equation. So just rearrange back the equation, the value from the calculation you have done above. So now, okay, the value of Vm, Im, okay, the value of the angle, okay. So rearrange back the equation, so you get a half 15 multiplied by 3 cos, the cos for the voltage is 90 minus 90 degrees, so you subtract which the value of the current, so minus and minus, you get plus here. Okay, so here half, just put back the value of magnitude of Vm and Im, so you get the value for the second part here. Okay, so the last answer is PT. So you get the last answer is 22.16 and 22.5 cos in bracket 2 omega t plus 10 degrees. The unit is in watts. Okay, so this is the one example of instantaneous AC power.